and today I'll be introducing the topic of Boolean algebra. Before we get into what Boolean algebra is, I'll first define what a Boolean is. Boolean is a form of dataset with only two values, commonly represented as 1 or 0 or true, false, etc. With that in mind, Boolean algebra is a type of algebra where it uses true and false only as the values of the variables and uses logical operators instead of arithmetic operators. Therefore, I'll first go over the type of logical operators and then move on to theories and laws regarding Boolean algebra and solve one problem. These are the basic logical operators in Boolean algebra. The first one is conjunction, which is also denoted as AND. Here are the main symbols for conjunction, which is the upward V sign, the multiplication sign, or simply AND. And conjunction returns true if both variables are equal to 1, and if not, it returns false. The next logical operator is disjunction, which is represented by the V sign or the plus sign or simply or. Disjunction returns true if only one of the value is 1 or both values are 1, and returns false if both values are 0 or false. The last one is negation, which is also denoted as not, and it can be represented as the variable bar or the variable prime or simply not, like x. And this simply returns the opposite value of x. So if x is 0, then not x returns 1. If x is false, it returns true, and vice versa. Here are the secondary list of logical operators that are important in Boolean algebra. The first one is NOR, which is the complement of OR. This simply returns the complementary value of OR. For example, 1 or 0 equals 1, or true or false equals true, but 1 nor 0 equals 0 as it is the complement of what the original OR returns. Similarly, NAND is the complement of AND. So 1 NAND 1 is 0, or true NAND true equals 0, false, and etc. And the last logical operator that is more commonly used than NOR or NAND is exclusive OR XOR, XOR, and it returns true if both variables are different. Unlike OR, where it can return true if it's true or true, exclusive OR returns false if it's true, XOR, true. There are various different laws in Boolean algebra, but in this lecture, I'll be only covering the most basic laws. The first one is the idempotent law, and it simply says a variable or a variable returns the original variable, and the variable and the variable also returns the AND variable. This can be simply proven using the truth table as 0 and 0 returns 0, and 0 or 0 returns 0, and 1 and 1 returns 1, and 1 or 1 returns 1 as well. The next one is the distributive law, and unlike normal algebra, both and or can be distributed. The first one is the AND distributive law, which simply says A and the parentheses B or C returns A and B or A and C. And the second one returns that A or parentheses B and C returns parentheses A or B and A or C. Using the idempotent law and the distributive law, there are other laws that can be proven, such as the absorption law. The absorption law states that A and the quantity A or B returns A, and this can be proven by distributing A and to A and A or A and B, which can be where since according to the idempotent law, A and A equals A, so it can be factored out again into A and the quantity 1 or B, and since 1 or B always returns 1, it can be simplified into A. Similarly, the OR absorption law states that A or A and B equals A, and using the same thing above, it could just be simply factored into A and parentheses 1 or B, which equals A, as 1 or B is always 1. Using the absorption law, the simplification law can also be proved. The simplification law is that A and the quantity A, not A or B, is equal to A and B. This can be proven by distributing A to both sides, which equals A and not A, or A and B. And since A and not A have opposite values, it will always return 0, which therefore can be shown as A and B, as A and not A will cancel out. The next one is that A or the quantity not A and B is equal to A or B. This can be proven by first using the absorption law of A and the quantity 1 or B, as it will always return 1, or not A and B, and distributing A to 1 or B will return A or A and B, or not A and B, which can be factored out into B with A or B and parentheses A and not A. And since A or not A will always equal to 1, it can thus be simplified into A or B. Using these laws, here is one practice problem where you can pause the video and try to solve. And it is simplify not X and Y, or Y and not Z, or Y and Z, or X and not Y and not Z. You can simply pause the video and try to solve using the 4 laws that I have demonstrated for. So the solution to the practice problem was that using the idempotent law on Y and not Z, on to create X, not X and Y, or Y and not Z twice using the idempotent law, and Y and Z and X and not Y and not Z. And then rearranging not X and Y, rearranging the two Y and not Z's to make the Y and Z go into the middle, so that you could factor the second and the third term into Y and the parentheses Z or not Z, and factor the fourth and the fifth term into not z and parentheses y and x, y or x and not y. And since according to the simplification law, y and x, y or x and not y is equal to x and y, and z or not z always equals to 1, as z and not z have opposite values, and one of them is 1. It can be simplified into not x and y, or y and 1, or z, not z and parentheses x or y, which the first and the second term can be factored into y and parentheses not x or 1. And since not x or 1 will always equal to 1, as 1 or anything is 1, it can be further simplified into y and z, not y or not z and x, or not z and y. And since y for the first and the third term can be factored out, it becomes y and parentheses 1 or not z, or not z and x. And since 1 or not z is equal to 1, the expression can be simplified into y and x or not z. So y or x and not z. So for final notes, Boolean algebra uses 0 and 1 or true and false as values for variables. And Boolean algebra mainly uses and or conjunction or disjunction and not as primary operators, and therefore can be mainly simplified using the 4 laws that I have demonstrated. Thank you for listening.